Alright, it's section 10.2. Last day we looked at the sum and difference. Guess what? Today we look at the products and quotients of functions. So, we're going to use the actual same two graphs from last time, but this time we're going to form new functions based on the product and the quotient. And of course, let me introduce to you the notation. I like to use this. It's f of x times g of x for the product. Yet your textbook likes to use this other notation, and that's fine. They're both perfectly fine. F, and they put a dot g, so that's f times g of x. The quotient, by the way, I like to just go f of x divided by g of x. The textbook likes f over g in brackets with an x. Okay? And by the way, it doesn't have to be f over g. It could be g over f too, right? Depending on what you decide. So, same two graphs, because you know what? It's easier to copy and paste. So let's go ahead and make a table of values, then determine the graph of this function. In this case, the h of x function is the product. And then once again, we'll do the domain and range, all that kind of stuff. So this time we're going to start at -4, so I believe the f of x values, okay, and these are the same as last time, so if you want to just copy them from before, you can. Okay, 4, 4, 4, 4, 4. And I guess for g of x, the same graph, I think that was 6, 5, 4, 3, 2, 1, 0, -1, 0, 0.5, 0.5, 0.5. Okay? And now for h of x, remember this is the multiplication, the product of the two, f of x times g of x. We'll get, I guess, -12, -5, 0 times 4 is 0. That's 3, that's 4, that's 3, that's 0, -4, back to 0, 2, 2, 2. Okay? And if we were to graph this out, let's take a look at what happens. At -4, it's -12, way down here off the charts, sorry. So let's do -3. -3 is -5. I can plot that point. -2 is 0. And then -1 is 3. 0 is 4, 1 is 3. You have a sense of what this graph looks like? Yeah, if you're thinking, this kind of looks like a parabola, you are correct. But then it changes, because this part's parabola-like, and then something happens here. Oops. And then, it goes back to 0, so back up to 0, and then it's at 2. So I guess it goes up to 2, and then 2, 2, 2, 2, 2. So something like this, and then across. All right. Now, if you're curious why part of it's a parabola and other parts are lines, let me try to explain that to you as well. Okay. Now, I actually should make this a little bit nicer, so I'm going to draw this again. Parabola, 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 up to this point. And actually between 2 and this is actually a line. And I'll show you why in just a moment. Okay? This is extra, by the way. Why is it a parabola throughout this part over to here? Okay, well, remember, this is h of x, which is multiplication, f of x times g of x. Well, if I asked you to use equations, what is the equation of f of x? Okay, so f of x for this part in yellow is represented by this line, and the equation of that line is, I believe, it's just x, and the y-intercept is 2, so it's x plus 2. Similarly, in this domain, the g of x function is given by that downward sloping line, so negative x because it's downward sloping, and this is plus 2. By the way, this is just extra, okay? Well, remember, we're looking for h of x. So in this region here, what is h of x if it's equal to f of x times g of x? Well, f of x is just x plus 2. G of x is negative x plus 2. What happens if I multiply them together? Negative x squared plus 2x minus 2x plus 4. That seems to simplify to negative x squared plus 4. And that is exactly what I see here. This is the graph of negative x squared plus 4. Now, you might be wondering, Mr. Lee, how did you know this other region that I'm going to highlight in blue here? How come this is a line? Well, if I wanted to do that here, once again, I'm going to ask you what is f of x for that region, and that would be this equation. I guess that would be just the number 4. And what is g of x? Okay, well, for that equation, it's still this line here, which is equal to, I guess, negative x plus 2. And so how do I calculate h of x? Well, it's just f of x, once again, times g of x. And if I multiply them together, what do I have? It's negative 4x plus 8. That's an equation of a line. And that's the line that corresponds to here. Okay? And the other two parts are very similarly done, so I'm not going to show you here. But once again, this is why we've got parts of it being a parabola, the other parts being lines. Okay? All right, let's turn the page. Guess what I want you to do next? We did multiplication. Let's do division. So consider the same two functions. I'm going to ask you to make a table of values and then find the graph of h of x, which is equal to f of x of g of x. Now, just a quick note, okay? If I asked you to find g of x over f of x, that is different, okay, than f of x times g of x, okay, or divide by g of x, okay? Multiplication, the order doesn't matter, okay? Just like addition, order doesn't matter. But subtraction, order matters. Same thing with division. The order matters. So once again, I'm going to ask you to fill in your table of values. Okay, we'll do this, negative 3, negative 2, negative 1, 0, 1, 2, 3. And I left something blank, so we'll go back to that, okay? So 4 for 2, 3 is also 4, 4 is also 4, 5 is 4, 6 is 4, okay? I'll come back to those blanks, all right? Stay tuned. G of x, once again, I think it's 7, 6, 5, 4, 3, 2, 1, and then we had 0, then we had negative 1, then it was 0, then 0 0.5, 0 0.5. All right, so if we're going to make table of values and plot points, h of x, once again, is just f of x, the numbers in red, divided by g of x, the numbers in green. So here we go. We've got the numbers like negative 3/7, negative 1/3, right? I reduced it. Negative 1/5. 0 divided by 4 is 0. 1/3. 2 divided by 2 is 1. This is 3. 4 divided by 0 is undefined. And if you're doing calculus, you get one of those asymptotes. Actually, you might have learned that in pre-calc 11. So undefined is an asymptote. Okay. Asymptote, that's those dotted lines. The graph goes closer and closer to that dotted line, but never touches. 4 divided by negative 1, that's negative 4. Oh, another undefined part. Asymptote once again. We'll draw those in a second. And then 4 divided by half, that's, I think, 8, right? Yeah, 8. 4 divided by half, another 8. Great. So go ahead and plot these points, and let's see if you can create and connect these things together. Negative 5 is about negative 3/7. Guess that's right here. Negative 1/3, negative 1/5, 0, 1/3. 0 is 1, okay. 1 is 3, okay. And then 2 is undefined. So remember how undefined we draw those vertical asymptotes, right? Once again, where the denominator equals to 0, that's where it's undefined. At 3, it's negative 4, so that's right here. Got another one of these dotted lines at 4. And then I've got at 5, it's 8, so 6 and 8 right here. 8, 8, 8. Okay. Well, if you're curious, I'm thinking I can connect these dots together. It looks something like this, and it must go up, 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 because it can't cross this vertical line, but it must get closer and closer to touch it. And then over here, I'm thinking, what happens now? what you can do is I can take a look at values between 1 and 2. Maybe I'll choose something like, I don't know, how about 1.9? So just to confirm that at 1.9 it's really, really big. Okay? Well, what's f of x at 1.9? So if I look at the graph, it looks like at 1.9 it's getting closer and closer to 4. So maybe call it a little bit less than that. Let's say it's like 3.9. Okay, this is an estimate, I know, but we're just going to use estimates right now just to confirm that the graph goes up, 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 up to the top. Okay, the y value goes up, 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 up to the top. G of x for 1.9, well, let's see, 1.9 is getting closer and closer to 0, but not really 0, so maybe that's 0.1. Okay, well, what's 3.9 divided by 0.1? Okay, not too sure. Bring out your calculator. But 3.9 divided by 0.1 is pretty big, 39. Okay, so notice it's getting big. And that makes sense because the graph here is getting big. Good. Well, let's see what happens a little bit after 2. So let's choose something like 2.1. Okay, we'll go back to our graphs. 2.1 is the number, oh, it's 4. We know it's 4 for sure. And then 2.1 for the g of x, that looks like it's negative, so maybe negative 0.1. And if I did that, that equals to negative 40, so that's really negative, big, way down here. Okay. I'm going to ask you to do the same thing close to 4, so I'm going to ask you to try 3.9. Okay, you can find the numbers. Okay, at 3.9, I believe this is still 4. And at 3.9, the g of x function, let's see, 1, 2, 3, 4, gets closer and closer to 0 again, but it's still negative. So once again, negative 40, way down here. Okay. And then curious what happens after the asymptote. Well, I'm going to try something like 4.1. This is still 4. I believe this is positive 0.1, so this is 40. This is big. So therefore, the graph, oops, I went too far. Must be way up here, and I guess it comes down and touches and it goes across. So ladies and gentlemen, there's your graph of h of x, which is f of x divided by g of x. Okay. Draw those in. And by the way, part B says state the domain and range, and I have a note here. Please don't forget when dealing with rational expressions or fractions, you've got to check for restrictions. And they occur, of course, from where the denominator really cannot be equal to 0. And in this case, since the denominator is the function g of x, okay, so I'll say in this case, g of x is the denominator. So we look for where g of x is equal to 0. And it looks like g of x is equal to 0 at x equals to 2 and x equals to 4. And that's why, and I'll say therefore, we have vertical asymptotes. And this is a review from grade 11 at x equals to 2 and x equals to 4. So if you're curious about the domain, then So if you're curious about the domain, for the domain we're going to have this. The domain is that you can say x can't be equal to 2 or 4, but it's everything else. Or if you like that set notation, just to bring that back, and for those of you taking calculus, you should know the set notation quite well. Negative infinity to 2, the union from 2 to 4, and then also the union from 4 to infinity. Okay, review that stuff from grade 10 if you don't remember. For those of you not taking calculus, who cares about that? This answer is perfectly fine. The range, once again, well, the range is a little bit more interesting in this case. Okay, you'll notice that it seems like this graph gets flatter and flatter here. It actually gets closer and closer to this line, -1. So it looks like the range, and if I were to shade in the y values that have the range, is from -1 all the way up, and then also down here from -3 and below. So to represent that, I'll say, well, y must be less than or equal to negative 3. Was that negative 3 or negative 4? Sorry, negative 4 I think it was. Negative 3 or negative 4? I'm confused. I graphed it wrong. Oops. See my mistake here? At 3, the value is negative 4. Oops, oops, oops. Time to erase. I hope you guys caught that. Thanks for telling me. Wait a minute, you can't tell me. I'm doing this by myself. Anyways, it's here, so my apologies. Let me then... Oh, you go change the graph, please. I'll go change the range right now to negative 4. And of course, the y value seems to be going from negative 1 all the way to what? I think it's, well, forever. So I guess I'd say it goes up forever, forever and ever. I can leave it like that, or some people like to write it as y is greater or equal to negative 1. Okay? If you like that interval notation, negative infinity to negative 4, square bracket because you want to include it, square bracket because you want to include it. There you go. All right. Well, the next two examples are just more practice like this, so I'll let you try those. But if you want to do it with me, I will continue to do it with you. We'll do 3 and 4, and then I think there's one more word problem, and we'll be done. The products and quotients of functions. Okay, example number 3, we've got these two functions here, root x plus 3 and g of x is x squared minus 1. So if I ask you just to find the equation of the function, that's the straightforward part. Just write down root x plus 3 times x squared minus 1. And in this case, you really can't simplify either, so no bother in trying to do anything more. That's good enough. Okay, it says sketch the graphs of all the functions on the same grid. So hope you remember how to graph out the parabola, at least for g of x. That's x squared minus 1. And by the way, if you want to make, once again, a table of values, you can. I'll do this. How about, let's say, negative 3, negative 2, negative 1, 0, 1, 2, 3. And I guess that'd be, what, 9 minus 1 is 8. Negative 2 squared is 4, 4 minus 3. Negative 1 squared is 1. 1 minus 1 is 0. Negative 1, 0, 3, 8. So if you want to graph that out, you can. And by the way, I tried to choose graphs that you already know how to do. So there's your g of x. So x and f of x. I'll use the same values. Okay, what do we have here? Negative 3 plus 3 is 0, square 0, 0. 1, root 2, I believe, root 3. That's just 2. 2 plus 3 is 5, so that's root 5. And then 3 plus 3 is root 6. If you're curious what these numbers are, 1.41, 1.73, 2.23. I forgot what root 6 was. Let me just quickly pull that up. What's root 6? Not one I use typically, so I forgot. 2.45. Yes, I should have remembered that. My bad. So you can graph these out. Beautiful, beautiful looking things. There's f of x. And then now it's your turn to try to find the graph of h of x. Well, h of x, once again, is the multiplication of all of them together, so I guess I'll do it over here. H of x, the same x values, right? And so let's multiply. 0 times 8, that's 0. 1 times 3, that's 3. 1.41 times 0, that's 0. 1.73 times negative 1 is negative 1.73. 2 times 0 is 0. 2.23 times 3 is about 6.69. 2.45 times 8, that's really big, so big. So if I were to plot these points now, I guess it's negative 3, 0, negative 2, 3, negative 1, 0, 0, negative 1.73, 1, 0, 3 becomes really big, so like already up there. So the graph kind of looks like this. Whee! And once again, do I extend this down here? The answer is no way, and I hope you know why. Because if I look at the domain of h of x, it has to follow the domain of each of these. The domain of g of x, of course, is all real numbers, the parabola. But the domain of the square root function, well, guess what? We have here x plus 3. The stuff underneath the square root has to be bigger than 0, and therefore x must be greater than negative 3. And that applies to h of x as well. Okay? Use the graph to find the range. Well, it looks like the minimum is right there at at x equals 0. So it looks to me that the range is about something like this. Okay. All right. Now I know this is just going to be an estimate because you're not too sure. If you wanted to actually do it properly to actually find out the real one, I'd ask you to then, why don't you graph it out on a graphing calculator? Okay. Graph it out on the graphing calculator. For those of you who have one, bring it out and use it. I'll quickly show you how to find the minimum. This is from last year, so I hope you learned this last year. I'm going to put in the function root x plus 3, close the bracket, and multiply that by x squared minus 1. We'll press graph, and you'll see the lovely graph, and that totally looks like my purple graph here, doesn't it? And then to find the minimum, I'm going to use the calculator's help, second trace, to give you the calculate menu. We'll choose number 3 for minimum, and then we'll move to the left of the minimum. Press enter. We'll move the cursor to the right of the minimum. We'll press enter. We'll press enter again, and there you go. Oh, so maybe it's not negative 1.73, it's negative 1.743, but nonetheless, you're close enough, and on a test, I'd give it to you. Okay, so I'll just say actual answer. The more proper one would be y is greater or equal to negative 1.74. Okay, but that's close enough. All right, you can do the same thing for example number 4. I think I'm going to be quiet now because you get the hang of it. So try example number 4 on your own, and then come back and look to see if you're correct. Equation of the function, this one, x minus 4 over x squared minus 2x minus 8. Some of you might be thinking, Mr. Lee, this is kind of interesting because I know I can factor the bottom into x minus 4x plus 2. Sure, if you can do that, by all means go ahead. And then you're thinking, hey, Mr. Lee, I can cancel these out or divide out. I'm like, sure you can. You're left with this. Sure you can, but don't forget, because this is a rational function, we have restrictions. And what are my restrictions? Remember that denominator cannot be equal to 0. So I guess x minus 4 can't be equal to 0. X can't be equal to 4. That's from this factor. And then I'll also have x plus 2 can't be equal to 0. Therefore, x can't be equal to negative 2. Okay. Once again, you're going to be asked to sketch the graphs of these functions. So I'm going to ask you to do that on your own. F of x minus 4, that's a line that intersects at negative 4, so that's not too hard, I hope. See how all this stuff from the previous grades is coming back? See how it comes back to bite you if you didn't learn math well the first time around? Okay, so there's f of x. This one, x squared minus 2x minus 8, is a parabola. I already found out from the restrictions, I know that, hey, if I make this thing equal to 0, I already have the x-intercepts. They are at 4 and negative 2. So I'm going to plot those out, 4 and negative 2. And then I can also figure out the actual y-intercept if I plug in x equals to 0. So the y-intercept is when you let x equal 0. So 0 squared minus 2 times 0 minus 8. So I know it's at minus 8. I can also find the vertex if you think about it, because the vertex is always halfway in between the two x-intercepts. So halfway between -2 and 4 is 1, and I can plug in 1 now. If I write down g of 1, this will be 1 squared minus 2 times 1 minus 8. 1 minus 2, that's -1, minus 8, -9. That's the coordinates of the vertex. Right? So here's my graph for g of x. Okay. All right. And if you're curious what the graph of h of x looks like, well, you already simplified it here, so we can actually just look at the simplified form. Now, if you don't want to do that because you're not too sure what the graph of 1 over x plus 2 looks like, then once again, make a table of values just like above, and you should get the same thing. But in this case, I'm going to use our restrictions of -4. So here, oops, I pressed something again, didn't I? No calculator. Go away, calculator. Go away, calculator. Go away. Sorry, everybody. Computer lags. Okay, so I will now plot -2 as an asymptote. You should have seen graphs like this last year, I think. Maybe not, not too sure, but whatever. And also at 4 there's a problem, but because they cancel out, it's not really an asymptote, it's what they call an open dot. Okay, but I'll do an asymptote too if you want. Actually, I won't. I'll just do an open dot. Anyways, if you were to graph out this function, this is the reciprocal function. So the graph looks somewhat like this. Okay. And like this. But once you reach 4, you'll see that something happens. You get like some open dot like that. And if you're not too sure, just graph it out in your graphing calculator and you'll get the same thing. Okay. State the domain. Well, once again, we've done that already. That's just a restriction. So remember, domain is x cannot be equal to 4 or -2. But then everything else after that is okay. So all real numbers after that. The range in this case, well, this function seems to get closer and closer to 0 on both sides, but not touching 0. So y can't be equal to 0. And by the way, you can always check this by using your calculator. All right. Okay, so one last one we'll do. That's the example number 5. Here's the word problem for this section. And once again, I'm going to bring back the idea of my math notes. And here I've decided that selling math notes just wasn't profitable enough. So what I'm going to do now is I'm going to sell some internet TVs. Yeah. But you know what? I can't do this forever, so I'm only going to sell them for 1 day, and I'm putting on a special promotion to do so. Here's the promotion though. Every hour starting from 1 p.m., the price of the TV will be reduced by 5%. So I'm going to start selling them at 12 noon, and every hour I'm going to reduce them by 5%. Reduce, 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 reduce until I'm all gone. Okay? Now the price, which I call P, of the television at T hours, after 12 noon, so T represents how many hours after 12 noon, is given by this function. P of T equals to 1,000 minus 50T, meaning I'm going to start with $1,000. I'm going to reduce it by $50 every single time. Okay? Now by doing so, I did some data crunching, and I found out that the number of televisions, that's N, sold at time T, can be modeled by this function 5T. Well, how do we find an equation to represent revenue? I hope you remember. Revenue equals to price times quantity. Now, this has to be in function notation, so I'm going to ask us to write this as R of T, since our variable here is T. The price is 1,000 minus 50T, and of course the quantity is 5T. So if you want to simplify this, I have here 5,000T minus 250T squared. And that's our revenue function. Okay, well, now that you have the revenue function, you should be able to tell me the revenue from TV sales at 4 p.m. Well, remember, T is the time after 12 noon. So how many hours have passed since 12 noon if it's 4 p.m.? Yeah, 4 hours. So therefore, T equals to 4. Wow, what's going on? So T equals to 4. Let's just plug that in. R of 4 equals to 5,000 times 4 minus 250 times 4 squared. And if you calculate that, I believe it's $16,000. So I've raked in $16,000. Not bad. Okay. A lot of times in business, though, it doesn't matter about how much money you bring in. It's about something else. It's about your percentage gain or your percentage loss. Of course, I want to actually gain. Now, the cost for each of my TVs is actually $650. Yeah, I gotta pay for them first. And so what I'm going to ask you to do here is I want you to find an expression to represent this thing called percent gain or loss in profit at T hours. Okay, now I told you how to calculate percent gain and loss. I know many of you don't take economics, but you know what? It's good to know this kind of stuff just because it makes you sound smart. So the percent gain and loss is calculated first by finding the difference between the revenue and cost. So I'll say percent GL, okay, that's gain or loss, is equal to finding the difference between revenue. So revenue minus cost, and then dividing it by cost, and because it's a percentage, I'm going to multiply it by 100. So let's go ahead and calculate this. Revenue, I know from above, right? We got that equation, 5,000 T minus 250 T squared minus cost. What's cost? Cost is $650, but it's $650 for each TV. So that's $650 for one, but how many TVs am I selling? Well, I'm selling TVs at a rate of 5T. Remember, that's my quantity, right? Quantity is 5T, right? Quantity is 5T. So you got to put that in. And I'm going to divide that by my cost, which is, of course, just the 650 times 5T. And then we're going to have to multiply this whole thing by 100. Okay, so I want you to simplify this, please, and let's see what we get as our equation. 5,000 T minus 250 T squared. 650 times 5, what's that? I think that's 3250. Double check my work. Okay, all over 3250 T times 100. Gonna simplify this because 5,000 minus 3250, I believe, is 1750 T minus 250 T squared, all over 3250 T times 100. I'm going to factor out, I think, 250, maybe T from each of these. I get 7 minus, I believe, T on the top, and then probably, let's see, well, I just write down 3250 T times 100. T's cancel out. Cancel, cancel. 250 and 3250. What was that simplified to? I think it's 13. Let me just double check. Oh, my calculator. My dear calculator. Where art thou when I need you? 250 divided by 3250. Okay, I want that as a fraction, so math, number 1, press enter. Oh yeah, 1/13. So we have here oh, don't forget, so 1/13. Wow, lag. So we have here 7 minus T over 13 with 100. So I think it's just 100 over 13 times 7 minus t. There's your equation for percent gain or loss. And to finish this off, I'm just going to ask you to calculate what is the percent gain and loss at 4 p.m. So all you need to do now is plug in what for t. And if you said 4, you are absolutely correct. So 100, 7 minus 4 over 13. 7 minus 4 is 3, right? So that's 300 divided by 13. I don't even know what that is. Yeah, so a little bit over 23%. So it's approximately 23%, and because this is positive, this is a gain. So I'm glad I'm making money at 4 p.m.